Kumusta? Can you see Can you see my PowerPoint? You can use the chat. Ito yung chat function. Pag nilagay niyo yung mouse yon. Pag nilagay niyo yung mouse ko sa taas, merong more. Tapat niyo lamang yung mouse pointer dun sa more, tapos lalabas yun. So you can ask question sa chat. Makikita ko naman yan. Tapos meron din itong raise your hand function. Ano? Okay, so we're still on chapter 2. So we're going to discuss the measures of flow. Ano? So there are several ways to measure the flow. Of course, the most common is the volumetric flow. Ano? So pag volumetric flow, halimbawa cubic meter per second, cubic feet per second, centimeter cube per second, ml per second. So ito yun. Ano? Kita nyo naman ang pointer, di ba? Ito yung volumetric flow rate, Q. Tapos, pwede rin naman na mass flow rate. Pwede rin mass flow rate. So siyempre, pag mass flow rate, kilogram per second, pound mass per second. Okay? And then, pwede rin molar flow rate. So, pag molar flow rate, pwedeng mole per second, mole per hour, kilogram mole per hour, pound mole per hour. Okay. So, halimbawa, yung mass flow rate at saka yung volumetric flow rate, these two are related by density. No? Kasi di ba ang density ay mass over volume. So, di ba ang density, density is mass over volume. So, density can also relate mass flow rate. So, kita nyo yung symbol ng mass flow rate, m dot, no? Yun yung convention ni Van Ness. Ang mass flow rate ay m dot. Tapos yung volumetric flow rate ay q, no? So, this is how you relate mass flow rate and volumetric flow rate using the density. This is density rho, ano? Tapos ganun din, ano? Yung mass flow rate, you can relate this sa molar flow rate. Di ba yung number of moles, if you still remember your chemistry, di ba this is simply mass divided by molar mass. Okay lang? Number of moles, mass, molar mass. Tandaan nyo pa? Tapos yung M is mass. Tapos yung capital M is smaller mass. Do you still remember this equation? Number of moles is equals to mass divided by molar mass. So at the same way, kamukha nitong sa density, you can also relate molar flow rate, that's n dot, no, to mass flow rate by dividing mass flow rate with molar mass. So ganun din, ano? So ang mga bagong equation natin ngayon sa thermodynamics ng chemical engineering, itong dalawa, itong dalawa. Okay, so do you have any concern? Do you have any question regarding these measures of flow? So there are 3 ways to measure the flow. Ano? Volumetric flow rate, molar flow rate, and mass flow rate. And then we have 2 equations to relate the 3 measures of flow. First is the density equation, and second is the definition of moles, no? Mass over molar mass. Okay. Let's proceed. Okay, so we have here an expression of the measures of flows in terms of velocity. So, di ba, have I mentioned to you that, di ko na matandaan if we have solved some problems Tapos, then we have stated that Q, no, yung volumetric flow is equals to velocity times area. Parang sa momentum ata yun, ano? Sa momentum transport. Pero, yun, siguro sabihin ko na lang dito, ano? Ulitin ko na lang ulit, ano? Yung volumetric flow rate Q ay equal sa velocity. Okay? So we're going to use this as the symbol of velocity. It's the velocity of your fluid times the area of the pipe. No? So halimbawa, imagine niyo ito yung pipe. Di ba ito yung area niya, yung cross-sectional area niya. So pag minultiply niyo yung velocity ng fluid sa loob, ng area, you're going to get the volumetric flow rate. So ang ano niyan, ang justification niyan, dimensional analysis lang. Kasi halimbawa ang velocity, 'di ba ang unit niyan feet per second. Tapos yung area naman halimbawa feet squared. So kita niyo pag pinag-multiply niyo yung dalawa, you're going to get cubic feet per second. And this is the unit of the volumetric flow. Okay lang? Okay. So that no one way to express m dot 'di ba ang we have this equation density is equals to m dot divided by q, no? So if you're going to replace q with velocity times area, yan no? So pag tinranspose nyo tong velocity times area sa kabilang side, you can show that ano m dot is equals to velocity times a times density. Ang ginagamit natin ngayong symbol ng dito kay Vanessa, no? Ang ginagamit niyang symbol ng velocity ay mu, no? Kasi yung velocity mamaya, yung B kasi ay reserved na sa volume, whether it's a specific volume or molar volume. So nakakalito kasi pag ginamit natin yung ginawa natin B yung velocity, no? Okay? Any questions so far? So that we have this equation, ano? So later gagamitin natin. Tapos ito naman, ano, this is the molar flow rate. So ito, mapapansin nyo parehas itong dalawa, pero kasi itong density dito is the molar density. So siguro huwag lang muna natin pansinin ito. Nakamali ko lang. Let's proceed. Let me clear this. And then annotating. Okay, so example 2.11. Basically, ganun yung ginagawa natin. Ano? We're trying to solve all the example. Okay, Vanessa, ano? Chapter by chapter. Kasi yung board exam, lalo na recently, ano, merong isang board exam na puro sample problem lang sa Banes yung lumabas. So, as much as possible, that's why I'm trying to discuss all the examples. Ano? This is example 2.11. Liquid hexane flows at a rate of 0.75 kilogram per second in a pipe with inside diameter D is equals to 5 centimeter. So the question is, what are Q? Q is the volumetric flow rate, and that is the molar flow rate, and mu is the velocity. Okay? So, yun, meron tayong m dot. So gamitin niyo lamang yung given na density sa dulo ng problem, yung 659 kg per cubic meter, masasolve niyo yung Q. Ano? Yung n dot naman, calculate niyo lang yung molar mass ng hexane, tapos divide niyo tong m dot, makukuha niyo na rin yung m dot. Yung velocity naman, di ba, Q is equals to B, velocity times area. So that's how you solve velocity. Ano? What would these quantities be for the same m dot if D is equal to 2 centimeter? So halimbawa ano, na niliitan nyo yung diameter ng pipe, no? Diba 2 centimeter na lang. So what would be the values, the new values of Q, n dot, and velocity? Imagine niyo, ano? So pag niliitan nyo yung pag niliitan nyo yung pipe, actually ang mangyayari doon, yung the same mass flow rate, if you have the same mass flow rate, constant naman ang density niyan. Pag liquid naman kasi hindi nagbabago yung density, ano? So if you have the same density, you will have the same volumetric flow rate. Parehas pa rin yan, ano? Yung, since parehas pa rin yung mass, hindi naman nagbabago yung molar mass, parehas pa rin yung yung molar flow, no? Molar flow rate. Ang magbabago lang talaga yung velocity. So velocity lang yung i-calculate natin, ano? Okay? So I hope you get what I'm trying to describe. Ano? So first, let's calculate Q. So sabi ko nga sa inyo, in calculating Q, gagamitin lang natin yung density. Okay, so density is equals to Q divided by M dot. So ang density natin ay 659 kilogram per cubic meter. Okay? Tapos ang ating mass flow rate, this is M dot, ano? Ilalim is 0.75 kilogram per second. So Q. So Q would be equal to, just use your calculator. So cross multiply nyo lang, ano? Ay, sorry, baliktad. Baliktad ang density ko. Ano ba yun? Clear. Nataka ako yun. M dot divided by volumetric flow. Tapos 659, no? Kilogram per cubic meter. And then M dot divided by Q. This Q is, M dot is 0.75, ano? 659, tapos 0.75, tapos Q. So Q would be equal to 0.75. Pag nag-cross multiply kayo, no? 0.75 divided by 65. So that would be, okay, I'm getting 0.0115. Alimutan ko yung 9. May 9 pa dito. Yan, sabi ko na nga ba, iba yung sagot. So 0.75 divided by 659. So yun, 1.14 times 10 to the minus 3. Ano? This time it will be correct. Ano? Q is 1.14 times 10 to the minus 3. This is in cubic meter per second. Okay? Kasi ito ay, yung 0.75 natin, kilogram per second. Tapos itong 659 kilogram per. So magka-cancel out yung kilogram. So that's why Q is in cubic meter per second. Any question regarding the calculation of the volumetric flow rate from mass flow rate? Basic lang naman yun. Sunod yung N dot. So, calculate muna natin yung molar mass ng hexane. Tandaan nyo pa, organic. So, ang hexane ay C6H. 6 times 2 plus 2. No, 6 times 2 is 12 plus 2 is 14. Tapos, ang molar mass ng carbon ay 12 plus 14. So, ang molar mass ng hexane ay 86. No? This is 86. So, di ba, N dot is equals to M dot. Okay. All over molar mass. So, N dot is, the mass flow rate is 0.75, kilogram per second. Tapos ito, if we're going to use 86, about grams per mole, ito kasi sa libro, about 86 yung ginamit natin. Kailangan nyo itong i-convert sa grams. So, multiply lang natin ng 1,000. So, this is used to convert kilogram into gram, So pag ganyan, you're supposed to get n dot is equal to 8.72. Ano? And that is 8.72. So this is mole per second. Questions? Do you have any questions? Do you have any concerns regarding these two answers? Okay. So, question. Yun yung question. Nakita ko. None po. Kaya madali lang naman kasi tayo. Na, so I'm going to clear this up again. Naka-record naman tayo na upload ko na lang. I'm going to calculate the velocity. So, velocity, ang gagamitin nating equation ay yung Q is equals to velocity times area. Okay? So, ang area ng circle, usually pipes naman are circle, ano? Cylinder, pero yung area niya is circle, di ba? So, velocity times pi over 4 tapos d squared. Okay? So, substitute natin yung given. Yung na-calculate natin kaninang Q, ano? Yung 1.14 times 10 to the minus 3 cubic meter per second. Tapos, we are interested in calculating the velocity. Tapos, times pi over 4. And then, yun, given na 5 cm yung diameter ng pipe. So, you need to convert this to meter. So, 5 times 10. Ang centimeter ay negative 2. Yan na, paulit-ulit na tayong So, nakukuha nyo na yan, ha? Yung halimbawa, 5 cm, tapos yung C, 10 to the minus 2. Papalitan nyo lamang yung C ng 10 to the minus 2. Automatic meter na to. No? So, squared nyo, and then you can calculate the velocity. No? So, bukan sa calculator, you're supposed to get something like 0.58 meter per second. Okay. Sa second part, you are asked to calculate Q again. So since hindi naman nagbago ang density, okay, you will find the same Q. No? So what I'm trying to say is Q2 is equals to Q1 kasi hindi naman nagbago ang density natin at hindi rin nagbago ang mass flow rate natin. So Q2 is still 1.14 times 10 to the minus 3. No? Meter cube per second. Yung n dot ganun din. Yung n dot 1 equal lang yun sa n dot 2. Kasi hindi naman nagbago hindi naman nagbabago ang molar mass ng hexane, ano? Ay, ng hexane. So, it's still equal to 8.72 mole per second. Questions at this point? So, ang ika-calculate lang natin yung bagong density, velocity, no? So, since dito manggagaling equation, equal yung velocity, ay yung flow rate, yung volumetric flow rate, constant. Okay? So kung constant yung volumetric flow rate, itong equation na to, velocity 1 times area 1 is equals to velocity 2 times area 2, no? Will also be true, no? This is specific to sa sa liquid. Kasi water to, di ba? Hexane, so liquid to. This is only true for liquid, ha? Mamaya we'll have some problem sa gases. Makikita nyo merong specific volume. So, sana hindi kayo malito. So, this is only true for liquid. This equation. Okay, so just simply substitute the given. Siyempre, alam nyo naman yung area, di ba? Pi over 4 lang yan, Tapos times yung diameter. So, ganun din sa kabila, So, magka-cancel out lang yung pi over 4. So, magka-cancel out yun, So, let's try to substitute the U1. U1 is 0.58, no? Ito, meter per second. Tapos, ang diameter natin is 5 cm. Kahit hindi nyo na-convert yung 5 cm, square nyo lang. Kasi magka-cancel out din lang yung unit yun. tapos U2. So, ang mangyayari dito, kung ano yung unit ng U1, yun din yung unit ng U2. 2 centimeter na lang, ano, sa square. So, finally, you can now get the velocity at the second pipe, U2. So, U2 is equals to 3.63 meter per second. Subukan. 0.58 times 25 divided by 4. Diba? You're getting the 3.625 meter per second. Do you have any question? Any question? Question? Yes? Question? Before we go to the next example problem. Okay. Wala naman. Yun. Wala. Okay, very good. Thank you. So, ito yung mga sagot. Ano? Tama naman yun ito. Ito yung Q, 0.00114, 8.70. Probably hindi pala sa molar mass natin. Ano? Velocity is 0.58. And then finally, the final velocity is 3.60. Parehas lang naman. Okay, so let's go to the derivation of our major equation. Ano? Yung energy balance equation natin. If you're going to consider this system, ano? We have this is our system. Ano? This is our system. This is where our control volume is. Ano? So kita nyo, meron pumapasok na mga flow. So this is M.1, and then M.2, and then may lumalabas na M.3. So, yung change in mass with respect to time ng system natin ay equal sa ito yung change in mass with respect to time, ano, dm dt is equal dun sa sum nung or yung difference, ano, pwede ring sum ng mga mass flow rate natin, ng mga flow streams natin. This is Fs is flow stream, Cv is the control volume, no? Parang imagine niyo mayroong tangke. Okay? Tapos maraming lumalabas, may isang lumalabas na flow, tapos meron dalawang pumapasok na flow. So, parang ganito yung system natin, ano? So, yung change sa volume or yung change sa mass ng tangke, sa laman ng tangke, ay equal dun sa relative difference nung lumalabas na flow dun sa pumapasok. Di ba? Parang ganyan lang naman yun. So this is our equation. Ano, tapos 'di ba yung m dot kanina dinefine natin na equal siya sa density times velocity times area. No? Basically, 'di ba sabi ko nga density is equals to mass over volume. So density times volume is equals to mass, volumetric flow rate. So that's why we have here velocity times area. Okay? So this is the continuity equation. Kaya lang, siyempre, ano lang naman yung i-consider natin dito, steady state lang, no? Sa industry naman, steady state din lang naman talaga yung kanyang system. So mawawala din naman to later, yung DMDT natin. Ito, steady state, no? So pag steady state, kumbaga pag sinabing steady state, yung laman ng tangke constant, hindi nagbabago yung laman niya, ano? Yung amount ng laman niya. So isi-zero lang natin to. So pag siniro niyo to, we have this equation, ano? So delta PUA, delta rho UA or delta density times velocity times area of different flow stream is equal to 0. So kung dalawa lang yung flow stream nyo, isang pumapasok, isang lumalabas, it is reduced to this one, ano? So, annotate this. So ito lang yan, ano? Density 2 times velocity 2 times A2 is basically equal to density 1 times velocity 1 times area 1. Okay. Actually, pag ang ano natin, if we have liquid, no? If we have a liquid system, so if we have a liquid system, yung density constant, ano? So we can cancel this out. So pag liquid, the equation is simply U1 A1 is equals to U2 A2. Kamukha nung ginamit natin kayo sa problem. Ano? Okay. Okay. Tapos, most of the time, di ba density yung row 1 at saka row 2. Most of the time, pag gases yung problem, tapos i-consider niyo yung density, doon nagbabago yung density. Hindi naman talaga density yung given sa gases. Ang given sa gases ay specific volume. No? Specific volume yung given sa gases. Ang specific volume ay reciprocal ng density. So, most of the time, ang ginagamit na equation sa gases ay ito. No? U1 times A1 divided by B1 is equals to U2 A2 divided by U2. Okay? Ito yung most of the time ginagamit na equation. Na? Makikita niyo mamaya. Let's try to solve a problem. So isa pang ulit, actually this problem specific ito dun sa change in diameter of a pipe. So if you're going to change the diameter of a pipe, ano ba yung mangyayari sa velocity? Na-imagine nyo naman, di ba? Pag lumaki yung pipe, syempre yung velocity babagal. Pag naman lumiit, yung velocity, pag lumiit, yung velocity bibilis. No? So, pag liquid yan, incompressible, tulad nitong problem na to, an incompressible density is constant liquid flows steadily through a conduit of circular cross-section and increasing diameter. At location 1, the diameter is 2.5 centimeter and the velocity is 2 meter per second. The diameter is 5 centimeter at location 2. So the question is, what is the velocity at location 2? Okay? So kung tandaan nyo pa, yung, di ba, dinerive na rin naman natin kanina. Basically, the equation for this problem is the equation for this problem is velocity 1, tapos i-square nyo lamang yung diameter 1, tapos equate nyo siya sa velocity 2, tapos i-square nyo lang yung diameter 2. Ganun lang yan. Ano? So, halimbawa ito, 2 meter per second, tapos yung D1 ay 2.5 centimeter. You don't need to convert pag itong ginagamit ka. Tawag dito continuity equation. Ano? Kasi kita nyo magka-cancel out naman yung mga units. Yung velocity ito yung hinahanap. Yung D2 ay 5 cm. So, yun. Calculate nyo lamang yung second velocity. Ilan? So, 2 times 2.5 squared divided by 25. So, 0.5. Ano? Are you getting 0.5? 0.5. Questions? Okay, so the second question is, what is the kinetic energy change in joules per kilogram of the fluid between locations 1 and 2? So kung tandaan nyo pa, ang kinetic energy, di ba ang formula ng kinetic energy ay 1/2 mv squared. Di ba? mv squared. So pag ang tinatanong ay delta KE, so this is simply B2 squared minus B1 squared divided by 2. Ganun lang, di ba? Do you agree? Yung mass kasi, saan punta yung mass? Yung mass kasi natin is 1 kilogram. So times 1, no? May times 1 dito, may times 1 dito. Usually, ganyan kasi yung problem. Ano? So, pag sinubstitute nyo dito yung velocity, so B2 is yung kanina, ano, itong 0.5. So, 0.5 meter per second, tapos squared nyo. Yung initial velocity natin ay 2. Ito. Ito. No? Yung initial velocity. Tapos divide niyo lang ng 2. Okay? And then use your calculator to solve this. Negative 1.875. No? So kung meter squared per second squared, yun yung unit niya, di ba? So anong equivalent unit nito sa joules? This meter squared per second squared is similar to joules per kilogram. Di ba? Question? Question kung nakita. Yes, very good. This is similar to joules per kilogram. Kasi tingnan nyo, ano, joules per kilogram. Di ba ang joules ay Newton meter? So per kilogram, ano? Tapos yung Newton, kilogram, meter per second squared. Tapos meter. Tapos may kilogram kayo dito. So kita nyo, magka-cancel out yung kilogram. So that's why joules per kilogram is the same as meter squared per second squared. Do you have any question regarding this problem? So sinolve ko lang to para makita nyo kung paano sinosolve yung velocity, no? Pag nagbago yung size ng pipe. Lalo na pag liquid, ano? So ganito lang yan, ano? Ito lang yung formula dyan. Questions? Any questions? So ito yun, ano? 0.5 meter per second at saka negative 1.875 joules per kilogram. Okay, so let's continue our derivation. Alam, 2 minutes na lang yung mangyayari. Ihinto. Tingnan lang natin kung ano mangyayari. So, ito yun, ano? This is the general energy balance. Ano? Initially kasi, di ba sa PChem, we have the delta U, tapos the Q and the W, ano? So, kaya lang sa ano, ngayon, pag flow system, meron tayong potential energy kasi di ba pwedeng bumaba, tumaas yung flow natin, ano? So may potential energy tayo. Ito yung potential energy natin, ano, mgh. Tapos may kinetic energy rin tayo kasi yung flow, yung velocity nung liquid nagbabago din, ano? So may kinetic energy din. This is it. Tapos yung volume nito, yung mass ng control volume nagbabago din pag hindi steady state. So meron ding D internal energy dt. Ito yun, ano? So masisimplify naman to, huwag kayong mag-worry. So for example, nag-steady state, mawawala itong term na to. Okay? Tapos ang matitira na lamang yung ito na lang 5. No, itong 5 yung matitira. Okay. So this is the open system energy balance equation. Ano? Open system. Hindi naman tayo siguro magsasolve ng open system ngayon. Ano? Steady state lang. So ang ginawa, susunod is hinati yung work rate. Ano? Hinati yung work rate. So, dinivide natin yung work rate into PV work